So we have read already the sample problem under colligative properties of solution, and it's an application of vapor pressure lowering, which will be using the concept of Rayleigh law. So I will read it again so that we can write down all the given information for this particular problem and use such in determining the required information. The vapor pressure of pure benzene is 100 torr at 26.1 degrees Celsius. Calculate the vapor pressure of a solution containing 24.6 grams of camphor dissolved in 100 ml of benzene. And you are given the density of benzene, which is 0.877 gram per ml. So we're going to take out the given information per sentence. So based on the first sentence, you are given the vapor pressure of pure benzene. So we'll have here A, P sub A equal to 100 torr. This is at a temperature of 26.1 degrees Celsius. So we'll define A here as benzene, which has the formula C6H6. Then the second statement is already asking for you the vapor pressure of a solution containing, so it says here that your solution should contain a mass of B, we'll define B later, which is 24.6 grams. And this B is camphor, which has this formula C10H16O. Okay, that's camphor in benzene. So the mass of, in this case, it's dissolved in benzene. So the volume of benzene, we'll just change this one to capital B, small b. The volume of benzene is 100 ml. And by the way, since benzene is A, we'll change this to A because camphor is B. We'll have here volume of benzene, and you are given here as well the density of benzene. So we won't have to keep on writing the formula. So we represented the camphor and the benzene with letters here, gram per ml. And you are required to determine the vapor pressure of the solution. The vapor pressure of the solution containing 24.6 grams of camphor dissolved in 100 ml of benzene. So that's the P. Okay, now we'll go to the solution. The solution part. So anyone here who has an idea what should be our starting point in here? What's our starting point? If I may ask you, or what would be the formula that you will write first? That way you will be guided to the solution of this problem, and that is finding the vapor pressure of the solution. What would be the formula that you're going to start with? Anybody? Let me check. Spinks, yes, you're saying something?
Lagid, miss. Bali, ang gamiton tamis nga formula is ang Rhodes law ni miss, which is vapor pressure with solute is equals to vapor pressure without solute multiplied by mole fraction, miss. Ang C10H16O para
Sige,
makita
sige.
ang vapor pressure.
You're correct. You're going to start, thank you, very good. You're going to start with, of course, the formula of Rayleigh's law. So we just need to polish what you said. So Rayleigh's law said that the vapor pressure of A, so the solute, our benzene is A, divided by the vapor pressure of the solution, I'll just place it like that, is equal to What did you say, Gana Speaks?
Mole fraction, miss, multiplied
Okay.
by vapor
Mole
pressure
fraction
without
of,
solute.
okay, mole fraction of A. I'd like to correct lang what you say that the vapor pressure without the solute. Now, this has actually the vapor pressure. When you speak of the vapor pressure of the solution, that already takes into account both the solute and the solvent. Okay? So the mole fraction of the solute is equal to the partial pressure of the solute divided by the vapor pressure of the solution. So when you speak of the solution, then it takes into account both the solute and the solvent. Are we clear about that, being? So it's not the vapor pressure without the solute, but rather it's now the vapor pressure of the solution, which actually considers both the solute and the solvent. So Spinks gave you already a platform, a formula for you to determine the vapor pressure of the solution. In that case, class, you are actually after this one. Okay? The vapor pressure of the solution. So for us to be able to find that one, I will just rewrite it. This one, so it's the, oh sorry. So this is the unknown, and we'll rewrite our equation in terms of this unknown. Meaning we will rewrite that we are now after the vapor pressure of the solution. So you transfer it here and this one in here. So you will have P sub A, partial pressure of A, over the mole fraction of A. So there you go. So for us to be able to find P of solution, we need to have vapor pressure of A or partial pressure of A divided by vapor pressure of the solution. Now, what do you intend to find first? If I'm going to ask you, this is now the formula that will find the vapor pressure of the solution. What will you find first? In here, based on the given. PA is already known, right? Given na siya. Vapor pressure of benzene, pure benzene is given. So meaning you need to find this. So what will we find first? If we are after the mole fraction of A, what do we do? If we are to find the mole fraction of A, by the way, what is mole fraction of A? Anybody? Mole fraction of A is equal to, unless you know what this is, you cannot place it in here. Unless you know the formula for the mole fraction of A in the solution, you won't have anything to substitute here. Who knows what is the mole fraction of A? When you are determining a fraction of something, it is like determining the amount of that thing in reference to the thing in which it's a part of. So in this case, you will find the moles of A and you divide that by the moles of A plus the moles of B. So in here, you're measuring the amount of A in reference to the total amount of the solution where A is a part of, just like what I've said a while ago. So if you want this one, then you need to determine, if this is equation 1, you need to determine moles of A. Okay? How do we find the moles of A? I'll go back to our given so you will be guided. How do you find the moles of A, which is the moles of benzene? How will you do it? Can you think of a way of determining the moles of benzene based on the given information? Wala gid. Okay, so somebody brought in the chat box. Multiply sa molecular weight, miss. Si Marby here na din ara sa waiting room. Okay. Okay. Thank you. Ako siya nakita. Multiply with the molecular weight. What will you multiply with the molecular weight, Yvonne? In terms of moles of A, you need the mass of A, which you need to divide by its molecular weight. The mass divided by the molecular weight will give you the moles, right? Now, however, in our case, you're given the volume and the density. How do I get the mass given the volume and the density? So I'll write here mass of A over molecular weight of A to get the moles. But the mass of A, based on the given, is actually the product of its volume and density. Volume and density, right? Density is mass over volume. If you multiply it with the volume, that should give you the mass of A. Then we divide it by the molecular weight of A. So look here, because I'm going to place the units. So the volume is 100 ml. And the density is 0.887 grams per ml. So 0.877 grams per ml. So you notice the ml unit for volume cancels, and that leaves you with the mass unit in grams. Now, what's the molecular weight of benzene? So you have to multiply 12 by 6 and you add 6. So that would be 78 for benzene molecular weight. So 78 grams per mole. So you cancel now the gram unit. That leaves you with the per mole unit in the denominator, which goes up to give us the moles of benzene. Can you solve, please, for the moles of benzene? One point 124. Correct. Thank you for those who placed the answers on the chat box. So 1.124 moles. Benzene. Okay. I need the moles of camphor, right? Benzene is dissolved in camphor. Remember, camphor is our B. So how do I find the moles of camphor? So same thing as the way we determine the moles of benzene. So that would be mass over molecular weight. So the mass of camphor is given here, 24.6 grams. And you divide it by the molecular weight of camphor. So this is the formula for molecular weight of camphor. Can you give me the answer? Okay. We have 0.16. By the way, what's the molecular weight of camphor? It's here 152. Please check because I don't have my calculator here with me, beside me. 152 gram per mole. So we cancel the gram unit and you have moles of camphor, which is 0.16 as written here on the chat box and shared by your classmates. Okay, thank you. So now you have already the number of moles of each, so you can find for x of a. So from equation 2, x of a, so we have 1.124 divided by 1.124 plus 0.16. This is for camphor and this is for benzene. So what's our mole fraction? 0.875. Yeah, correct. So Marby is correct. 0.875. Now, since you already have XA from 1, PA or P of solution is equal to, this is our one for everybody to see. PA over XA, and PA is 100 torr. 100 over XA, which is 0.875. So the P of solution is 114.286 torr. Wait, ha? We'll go to our formula. So PA over P solution. So P solution equals to PA over XA. And this is our answer, 114.286. Okay, let me check on the chat box. Okay, that's 114.286. Now, any questions? Any questions, class? Okay, if you want to take a screenshot of the solution, you may get it now. You may take a screenshot now. So this is for the first page. Second page. Third page. And the fourth page. I'd like to check first because our topic is vapor pressure lowering. So we expect the vapor pressure of the solution to be lowered because of the presence of benzene. So let me check first the, wait guys ha, the slides on it. We have solutions. Okay, I'll stop sharing for now. I'll go to Canvas and share to you the slides on this topic. So we can check because that's under colligative properties of solutions. And I'll show to you the PowerPoint. So I will be able to point out to you the application of the said topic, colligative properties of solution and vapor pressure lowering. Okay, I'll share to you the slides now. Okay, you'll just have it on projection. Because in terms of the formula that was shared to us a while ago, this is the formula for Rayleigh law. Okay, let me just check if you could see the slide in projection mode. So that's it. Rayleigh's law, PA is the vapor pressure of the solute, and PA naught is the pure vapor pressure without the solute. So this is the thing that Spinks mentioned a while ago. The term is the vapor pressure without the solute, and XA is the mole fraction of the solution. So the way we have written it in our Jamboard, so I'll go back to Jamboard. Please take note of this. Okay. PA is equal to XA PA naught. This is the vapor pressure without the solute, or that's the pure vapor pressure of the solution. Okay? So that is why we have vapor pressure lowering. We expect that the pressure that we'll be able to get is lower than the original pure vapor pressure. So please take note of this formula, and I'll go now to the Jamboard. Okay? Okay, class. Share again. Like to go to the first slide. Hope you can see the Jamboard already. Now, the one that Spink said that the vapor pressure without the solute is the pure vapor pressure. So this PA that we write here is the pure vapor pressure of benzene. If you have taken a screenshot of the problem, it's not just that we're going to purely compute, but we need to have understanding in what we are computing. So let me just check about the picture I've taken. Okay. So I hope you have taken a picture of it as well. And here it is. It says here, the vapor pressure of pure benzene. So meaning it does not have the solute first. So in this case, class, since the starting sentence is saying the pure vapor pressure of benzene, so meaning benzene is not your solute in this case. Your solute is your camphor, the B, which is C10H16O. Okay? Again, the first statement says the vapor pressure of pure benzene. So it's the pure benzene wherein you're going to dissolve the camphor. And camphor then is your solute. Remember that you are even given in the problem the volume of benzene that was used in dissolving the camphor, and you are given its density. Okay? So this is PA not PA. Now, so you have to correct your notes there. And if we go to the next slide for our solution, our formula in here should be, in this case, I'll erase this one. This should be your PA knot. And this is your PA, or this already the vapor pressure of your solution in which you have dissolved the camphor on benzene. This will now be similar to the formula of Rayauld's law. The formula of Rayauld's law is PA equal to XA PA naught, as shared to you on the slide. So we need to correct the formula that we have written a while ago. Pure vapor pressure of benzene is the vapor pressure without the solute. So if you're going to have this cross multiplied, this will look exactly as the formula of Rayauld's law. And the vapor pressure of the solution will now take into account PA, the vapor pressure of the solution in which your camphor is being dissolved by your benzene as the solvent. So in this case then, your PA of the solution, as you could see in here, will be not this formula, but so we need to correct this because the answer that we are getting upon rechecking is not lower than the original vapor pressure. Since our colligative property says that there should be vapor pressure lowering, if you cross multiply this one in here, so this should be XA PA naught. Okay? So please change your notes there. Your P of solution should constitute the product of XA and PA naught. Okay? There's nothing wrong in here. There's nothing wrong in here. This is still your XA. Nothing wrong with that. It's in the Rayauld's law that we made the mistake. So that is why our answer is higher than the expected vapor pressure lowering concept. So we expect that the vapor pressure of the solution will be lower than the pure vapor pressure of the solvent. That's the vapor pressure without the solute, which Spinks read a while ago straight from the slide, or based on what he can recall. Okay? So in this case, if you go from 1, it's XAPA naught. So we'll have this one now change to, just change this. Your XA is 0.875 and PA naught is 100. So your vapor pressure of the solution is 87.54, lower than the original vapor pressure of pure benzene that was used as the solvent. Do you get it, class? Do you get my explanation? So in a way, when you solve, you should always check, or you should go back to the concept that is being used in solving that particular problem. You are asked to determine the vapor pressure of the solution, which is supposed to be lower than the pure vapor pressure of the solvent benzene. So kaina na balang tagidayon nga hindi amo ang formula nga gingamit based on what I have written on the start of the slide is because the answer is greater than 100. Now, any questions? So this should be, so the corrected part is in here, the pure vapor pressure and the formula for Rayauld's law. The rest is okay until the part wherein we determine the vapor pressure of the solution. Any questions? So no question here. Sige. So we go to the second sample problem and you have taken a screenshot of that as well. So may I ask somebody to read that particular problem? Can I ask for Christine Landas to read sample problem number 2, this time an application of freezing point depression.
Good morning, Miss.
Morning.
Freezing point depression and boiling point elevation. Ethanol glycol or EG, CH2, um, OH and CH2OH is a common automobile antifreeze. Calculate the freezing point of a solution containing 651 grams of EG in 2,505 grams of water. Would you keep the substance in your car during radiator during the summer? The molar mass of EG is 62.01 grams per mole, and KF equals 1.86 degrees Celsius moles, and KB equals 0.52 degrees Celsius for water.
Okay, thank you. So actually, this one, what was read is the Kf is the molal constant for freezing and Kb is the molal constant for boiling point elevation. The freezing is freezing point depression. Before we even start solving this problem, class, let me explain. If it's freezing point depression, we expect that the freezing point will go lower. It will decrease, okay, due to the application of the solute in the solution, whatever that solute may be. If it's boiling point elevation, we expect that the boiling point of the solution will be higher due to the presence of the solute. So the two are two opposites. Freezing point will go lower due to the presence of the solute, and boiling point will go higher due to the presence of the solute. So both are opposite. So in this case, you're given ethylene glycol. Right? So we will write the information again as extracted from each of the statement of the problem. So you're given ethylene glycol, so EG, and its formula is CH2OH, CH2OH. So ethylene glycol, which is a common antifreeze. And then you have the amount of EG dissolved in water. So mass of EG is 651 grams, and the mass of water is 2,505 grams, which is this. So this is 651. Okay. What else? You are given the constants Kf, 62.01 gram per, actually class, this is not per mole, but per molal, molality. Kb is equal to, sorry, the 62.01 gram per mole, it's really per mole, is molecular weight of Eg. Okay, I have read it. I have placed the wrong representation. So this is molecular weight of Eg. So there's no need for you to get it from the periodic table. The Kb is 0.52 degrees Celsius per molal. Okay, that's not mass, ha? And Kf is, for Eg, is 1.86. Kb is 0.52 degrees Fahrenheit Celsius and 1.86 for Kf. This is for your solvent water, not Eg. Okay? The molal freezing point depression constant and molal boiling point elevation constant is based on the solvent, which is water. So you are required to, so what is being asked in here? Calculate the freezing point of the solution. So we are asked for the TF of the solution. And then there's a question. Would you keep the substance in your car radiator during summer? So question is, will EG be still used during summer? Or it's just a rephrase of the question, would you keep the substance, it's referring to ethylene glycol, in your car radiator during summer? So ginabutang na siya sa radiator, sa salakyan para hindi siya mag-freeze. Actually, this is used class in countries in the western part of the globe where there is snow or there is winter. So, ang tubig ara sa radiator nga nagapabugnaw sa engine, part nga nagahelp pabugnaw sa engine sa salakyan, will freeze without this antifreeze. So that is why they putting it there. So the question is, will ethylene glycol be still used during summer, or should this EG be still used during summer? So the answer there will be just a simple case of yes or no. Okay, so we go to the solution. Okay, so this is your given if you'd like to take a screenshot. How do we start solving this problem? Again, what do we need?
Molality, miss.
We will start with the what first. We will start with the, what do we need to start writing?
Formula, miss.
Okay, correct. We need the formula. So whether it's freezing point depression or boiling point elevation, we need to start with the formula. So in this case, you're asked for the freezing point of the solution. So what's the formula in determining the freezing point of the solution? What's the starting formula that we could use?
Delta TF is equals
Okay.
to KF times molality, miss.
Okay. So it was correct a while ago when it was mentioned that we will start with determining molality of the solution because this one is already given, the KF. Now, what about the delta TF? What's your understanding of the delta TF since this is the freezing point depression of the solution? So what is this? The delta TF is by the way what? That would be freezing point of the solution minus freezing point of pure solvent. So that's the delta TF. What's the difference between the freezing point of the solution and the freezing point of the pure solvent due to the addition of the solute? In this case, our solute is ethylene glycol. Okay? Now, what's the freezing point of our solvent in this case? What's the freezing point of water?
0, miss.
0.
Celsius.
Okay. So you will have here of the solution, this is just 0. So we'll just place here KFM. Okay. The freezing point of the solution will just be KFM because this one is just 0, which is the freezing point of water. Now, so we will need to find the molality. Okay, so we're done with ways of expressing solution concentration. What is molality?
Moles of solute over kilogram of solvent, miss.
Okay, very good. So kilograms of it. So need to find the moles of solute. So our solute is ethylene glycol and its mass is 651. So you will have 651 grams. You need to divide that by the molecular weight of ethylene glycol, which is 62.01 grams per mole. So the unit now in our numerator is mole of EG. Now in kilogram solvent, we're given here the mass of the solvent. It's in grams, so it's 2,505 grams. So you just need to convert it to kilograms. So you divide by 1,000. So we cancel the gram. So you now have moles of solute per kilogram of solvent. And what is our answer?
10.498 moles, miss. Ay,
Then, yes.
4.19 4.190 molality gali, miss.
Sige. Okay, the others, please just check ha. It's normal to make mistakes in the computation. So 4 point, was not able to get it. You have 651, you divide it by 62.01. You multiply it by 1,000 and you divide it by 2,505. So it's 4.19. 19 molal. Okay? Sige. So we have that and we have the KF. So freezing point of the solution is equal to 4.19 and we multiply it with the KF. 1.86. So you have 7.795 degrees Celsius. Now, the freezing point of the solution, so it says there, freezing point depression. The freezing point depression. So we expect that there will be a lowering in the freezing point of the solution. So what should be our final answer? What's the freezing point of the solution?
Negative, miss.
Okay, so it should be negative 7.79 because the freezing point of water, you have to understand, the freezing point of water is 0 degrees Celsius. Now, it's just saying that if you have water and you put, pilaning mass ng ethylene glycol, you put 651 grams of ethylene glycol in 2,500 grams of water. Instead of water freezing at 0 degrees Celsius, your solution now, the freezing point of your solution will be much lower than that. So your final answer should be negative 7.795 degrees Celsius. This is how much the freezing point of your solution would be because of the presence of the ethylene glycol. Because without the ethylene glycol, your water, no matter how small the amount is or big the amount is, it will really freeze at 0 degrees Celsius. But due to ethylene glycol, you need it to be lowered below 0 for it to be able to turn solid or for it to freeze. Okay, so that's the freezing point of the solution. So any question here? Now, as to the second question, if there's no question as to letter A, will you use still EG for summer? Will you still place the antifreeze ethylene glycol during summer in your car radiator? Okay, so anybody would like to answer? Sige. So you can't have it answered for now because you need to first determine what would be the boiling point of your solution with the presence of EG. Okay? So we'll have TB solution is to be subtracted by TB of water, pure water. And this is your delta TB in the formula, which requires K sub B and molality to be multiplied. Now, if we will multiply this one class, this boiling point of water, I'll place here TB solution. Boiling point of water, pure water is?
100, Miss.
So, 100. So, that's your delta TB based on this formula. Your KB, go back to our given, is 0.52. 0.52 degrees Celsius and per molal. And we multiply it with molality, which is 4.19. So we cancel. So how much is the answer here? 0.52,
2.1788.
2.1.
788 degrees Celsius, Miss.
Okay. So I go to the next slide, ha? Boiling point of the solution is equal to then your answer here, which is 2.18, just rounded off to the nearest whole number, two-digit whole, two decimal places. So 2.18, and you have this class 100. So it should be added here because it's minus on the other side. See this one minus. If you transfer it here, that would be positive. So you have now the boiling point of the solution as 102.18 degrees Celsius. So this would be now the boiling point of your ethylene glycol in water solution with the presence of ethylene glycol. So since we have determined already the boiling point of the solution with the ethylene glycol, the question is, will you still be using ethylene glycol during summer? If you are, let's say, imagine yourself you're there in the US or in Canada, or especially those parts of the globe wherein it really snows hard, will you still be keeping ethylene glycol in your car radiator, knowing that the boiling point will be 102.18 degrees Celsius? What do you think will be your answer? What should be the correct answer? Can you place your answer on the chat box? We'll see who can be able to apply the concept that just solve the formula. So what do you think? Will you keep the ethylene glycol in your radiator fluid during summer? Yes or no? Oh, wala. Gid sa maisog nga magpalagpat, oh. Palagpatin nyo na lang. No, but you have to apply the concept of boiling point elevation in this case. So the answer is yes, miss, kay mas taas ang boiling point yeah, kaysa sa pure water, which means it's much better. Eugene says yes. What about the others? So Miss Ali forgot that others doesn't have a name. So what about Freda, Angelique, Cassandra, Cello, Chelsea, Sherry, Christine, Karil, Lance, Marby, Micah, Spinks, and Yvonne? Will you place your answer on the chat box? We'll see. Okay, Cassandra already answered. What about the others? Will you still keep the EG in the radiator fluid? In this case, that's just water. Here in the Philippines, however, ang new cars class, wala na tagadugang, wala na tagadugang tubig sa radiator. Kung ano, pagbakal mo siya, mo na siya. Lain pa sang una, yang ang mga salakyan, ginatugungan, no pa gina-refill mo ang tubig, ang radiator sa tubig, para hindi siya ma-overheat. Sige. So there are only 3 brave souls here who will give me a specific answer, yes or no. Actually, class, it's just a yes or no, but it's a reflection of your understanding whether is it really important, this subject matter that we're discussing, is it really that important in day-to-day observable phenomena? Like in the simple case of putting in or making sure that your radiator fluid is, let's say, always in the normal level or has the presence of an antifreeze if you're in the snowing part of the globe. So, tatlo lang. So, I admire these 3 people if they are just the ones who would rather make a mistake and learn than rather not give any answer at all. Para safe miss, ani nilang kung magatag answer. Cherry said yes. Oh, don't be afraid to commit mistake if that mistake will make you learn, because there's no mistake at all if you keep on learning. Na kung sige lang, kaya inabalang gahulat ka lang that things will be answered for you, then you don't acquire that confidence na I am not learning because di gani ko confident mag-answer sa ginapamangkot sa teacher. There's nothing wrong with not learning at the start because hindi man tayo palariho tanan pace ang learning. We don't learn in the same pace as others, may learn faster than others, but what is important is you keep learning. So, not sure, Lance is not sure, Sphinx, yes. O, yes na siya. Okay. We don't anymore but you're saying, Lance, that you're going to still going to put in EG. Because whether it's altered or not, you're going to place in. Okay. Okay, class. The answer is actually a yes. The answer is yes. The antifreeze, which is used as, of course, as an antifreeze for pure water during winter in radiator fluids because they don't want, of course, the water to freeze. Otherwise, they won't have a coolant. Okay, it should still remain there during summer because instead of water boiling at 100 degrees Celsius, due to its presence, its boiling point would be increased to 102. So much higher siya mag-boil ang water. So kung mas higher mag-boil ang water, hindi mag-init ang imong makina. Okay? As simple as that. So we want as much to increase the boiling point of our water so that our engine will not overheat. So the presence of the antifreeze would rather stay there in your radiator fluid whether it's winter or summer. That is if you are in that particular part of the globe. Okay? Here in the Philippines, we don't put an antifreeze but rather what we put is engine coolant. So ginapa-cool down niya ang aton nga radiator fluid. That way, hindi magkita pang aton nga engine. So that's it. So the answer is yes. So therefore, we keep ethylene glycol in the radiator fluid even during summer. So Eugene was very correct. Okay, the reasoning of Eugene is correct. Okay? Sige. We'll have a 10-minute break. We'll discuss, I think, short problems na lang siya ang nabili. Okay? A 10-minute break then. So this is our third sample problem. A 7.85 gram sample of a compound with empirical formula C5H4 is dissolved in 301 gram of benzene. The freezing point of the solution is 1.05 degrees Celsius below that of pure benzene. What are the molar mass and the molecular formula of this compound? So the molar freezing point depression constant for benzene is 5.12 degrees Celsius per molar of solution. So take a screenshot of the problem so we will have, we don't need to go back to the problem once we are in Jamboard already. Okay? Okay. So we'll go back in Jamboard. Wala siya naka-screen
Miss,
share.
excuse, hindi naman makita ang problem, Miss.
Okay, share ko ulit. Can you see the problem already? Can you see the problem already?
Yes, miss.
Okay. Kindly get a screenshot of the problem so we don't need to go back to this document once we're in Jamboard already. Okay.
Goods na, miss.
Okay. So we'll go to Jamboard now. And this is our third sample problem. Okay. So we'll write down as usual all the given information. So it says here the first statement, a 7.85 gram sample of a compound of empirical formula C5H4. So I place here the empirical formula is C5H4 and the mass is 7.85 grams. Now it's dissolved in 301 grams of benzene. So this is our solute and the mass of the solvent, just place solvent. The benzene is 301 grams. The freezing point of the solution is 1.05 degree Celsius below that of pure benzene. So we'll just write delta TF because we don't know the freezing point of pure benzene, but this is already the depression. So this is how much the freezing point of pure benzene lowered due to the presence of the compound with empirical formula C5H4. So that's delta TF, and you're given the molar freezing point depression constant of benzene, which is 5.12 degrees Celsius per molar. So you are required here to determine the molar mass of the compound. So this is its empirical formula. So we are after the molecular mass, okay, of the compound. We can even place here its molecular formula because it will just simply follow and then I just add it on there. Okay, what are the molar mass and the molecular formula of the compound? So those are the two required information. Okay. So this problem is purely an application of the molar freezing point depression. So we're going to place in here the formula Kf times molality. Okay. To be able to get the molality here, keep it here, you will have delta TF over KF. And that would be 1.05 divided by KF, which is 5.12. So can you please give me the answer? 2.205. Okay, that's our molality. Okay, I'll place here 0.205 is actually moles solute over kilogram solvent, right? That's molality. And that molality we're able to solve in here. Now, you already have the mass of solvent, which is 301 grams. So we'll just convert that to get the moles of solute, we just convert the 301 grams to kilograms. So 1,000 grams to 1 kilogram. Okay? So 301 times 0.205 will give you the moles of solute. Can you please give me the answer? 0.205 divided by times 0.301. Answer is 0.06171. Okay, please check. You do cross multiplication 0.205 and 0.301. That's 0.60171. Now, this moles of solute is actually the mass of the solute divided by its molecular weight, right? So the molecular weight gives you the molar mass. So in this case, molecular weight or molar mass is mass over number of moles. So the mass of our solute is given, it's 7.85. And you need, this is grams, and you need to divide it by 0.06171 moles. So your answer is 127.21. So this is gram per mole. Okay, those are correct, Marby and Cherry. So 127.21. But we've learned, so this is already our first answer. Molecular mass is 127.21 gram per mole. Okay? Now, as to the molecular formula, what do we do? We are given the empirical formula, EC5H4. So if empirical formula is C5H4, empirical mass is equal to, you base it to this one. So that would be 12 times 5 plus 4 times 1. And that would be equal to, this is 60. And that's 64 gram per mole. So in terms of the multiplier, if you can still remember our topic of empirical and molecular weights, the molecular weight we divide by the empirical weight or the empirical mass. So this 121.21 127.21 rather, we divide by 64. Divide by 64, giving you a 1.98. So more or less, it's a 2. So therefore, the molecular formula will be your empirical formula. Thank you, Marby. So your molecular formula will be times 2 for each of the subscripts that appear in the empirical formula. So that would be C10H8. So this is the molecular formula. The molecular mass is that one. Okay? Sige, I'll go back to the first part of the solution so you can get a screenshot. Anyway, you have the recording to be shared. So that's it. Then you have this. And you have this. Okay. Sige. So last sample problem is on the application of the osmotic pressure. Okay, I will share again the document to you. By the way, have you taken a screenshot? So we'll just anyway share it again. Osmotic pressure. Calculate the concentration of urea that has an osmotic pressure of 30 atm at 25 degrees Celsius. Calculate the concentration of urea that has an osmotic pressure of 30 atm at 25 degrees Celsius. Okay, so we'll share the Jamboard. This is, by the way, our fourth problem. So given. The problem starts with a question. So we'll just pick out the answer on the question. I will just pick out the given on the question. Urea has this formula, NH2 CONH2. Right, that's your urea, and then osmotic pressure, that's pi, 30 atm. Temperature is 25 degrees Celsius. You are required here for the concentration. So the concentration, most of the time, class, if it's in association with osmotic pressure, is molarity. Moles of solute per liter of solution. So this is actually the simplest of the colligative properties of solution because you will simply recall the combined ideal gas law equation. Okay, so you'll have here osmotic pressure is this P, we just change it to pi. So P is equal to N over V times RT. This N over V, moles per unit volume, is molarity, MRT. And we change the P to pi. So pi is equal to MRT. If you want M is equal to pi over RT. And what is pi? 30 atm. So we will use the universal gas constant, which is 0.08206. ATM, liter per mole Kelvin. Then we multiply it to the absolute temperature. Always remember that your temperature using ideal gas law should always be in absolute form. Atmosphere. So you'll have now the unit mole per liter. So the concentration, the molar concentration is 30 divided by 0.08206 divided by 298.50. Your answer is 1.23 molar. Okay. So this is the end of the problem applications on colligative properties of solution. Do you have any questions? On Wednesday, we will not meet. You will have the time for the uh, practice exercises in the problem sets. So comply with the problem sets given the time on Wednesday. That way you can use your other time for other things to do. Okay, any questions here? Okay, I will. Sige. So I'll start with the first slide. Okay, that's the first slide. Second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10. Oh, sorry. 10, 11, 12, 13. Okay. It's okay. Welcome. So Wednesday, do your problem sets. Okay, we'll see each other next week for your quiz. Okay, please check your schedule in the announcement in Canvas as to what will happen next week when we have face-to-face. Okay, don't hesitate rather to message me should you have any concerns in our course.